Hi, I'm Zor. Welcome to Unizor Education. Let's continue solving problems in solid geometry. We are still talking about lines and planes and points and perpendicularity and parallelism. And the problem which I'm going to present is part of the advanced math course for teenagers, which you can find on unizor.com. This site contains notes to this lecture, which basically explains everything which I'm talking right now about, and I do recommend you to read these notes before or after the lecture. Now, as usually, I have basically said it many times, and let me repeat. Whatever I'm going to talk about, it's not something which you will need in your practical life. This is just an exercise of your mind, of your analytical abilities, and the purpose is to develop these analytical abilities and creativity and logic, because in your real life you will meet certain challenging problems which you have not been told how to solve. So basically it's up to you to solve something which is unknown before, or at least unknown to you or the company you are working in. So it's very important to be able to prepare your mind to look for solutions, and I know that in many cases schools are just giving you recipes like this is the problem and this is the solution. Okay, so any problem like this should be solved like that. I don't think that the practical life is like that. Practical life gives you a lot of different cases when you have to just invent something which nobody invented before you. And that's where the problems like these are very handy. It would be great if you can solve these problems yourself. If you cannot, listen to the lecture, read the notes, and then try to recreate whatever I'm going to say about this problem. And that's the same for every problem which I'm presenting. That's the best approach. Okay, now, enough talk, let's just do the problem. The problem is as follows. You have two skew lines which are not parallel and are not, you know how to probably better display them on the board? I will draw a couple of planes, and it will be visible that the planes are different, and I will draw lines inside these planes. So let's say this is one line and this is another line. So these are completely unparalleled, non-perpendicular, non-parallel, non-intersecting, whatever, lines. And what you have to do is you have to draw a line in between them which is a common perpendicular. So if you combine this line and this line in a plane, and in that plane that would be perpendicularity here. If you take this line and draw a plane through these two lines, this would be a perpendicularity. So each line is perpendicular to this joining segment, or a line, whatever, along this segment. So the question is how to construct it. Now, before I was just saying that the lines are skew, which means non-parallel and non-intersecting. Now, if they are parallel, which means they are lying in the same plane, two parallel lines, it's very easy to draw a perpendicular which is perpendicular to both of them. And there are many of these. You know how to do that in the plane geometry. If you have a plane, parallel lines, to draw a perpendicular to one of them will be perpendicular to another, and that's it. If lines are in the same plane, if they are intersecting, then there is no such thing as a mutual common perpendicular, because no matter what perpendicular you draw to one line, it will not be perpendicular to another, because otherwise the lines will be parallel and not intersecting. So that's why I said from the very beginning that the problem is not trivial. That's why the lines are skew, non-parallel and non-intersecting and non-lying in the same plane, therefore. Okay, so let's put some letters. Now disregard these planes. These planes are just for illustration to show that the lines are in different planes, different stratas. So this line is A, this line is B, and that's all I know. Two lines in the space. So first, let's just analyze the problem. So I know that this line is perpendicular to both. Well, that actually means the following. If I will have a plane, let's just assume that I know these 2 points, A and B. I mean, I don't know. I mean, it's actually, the problem is all about finding these 2 points. So if I know, let's assume that my common perpendicular does exist. This is from point A to point B, which I still have to find. Now, let's just think about it. AB is perpendicular to A. Now, at line A, at point A. Now, where are all the different perpendiculars to the line A are lying? What's the locus of all the different perpendiculars to line A if we are talking about a three-dimensional space? Well, obviously it's the plane which is perpendicular to line A. So let's put this invisible. All right. So this, well, actually this part is invisible. Right. So this plane, let's call it sigma. Sigma is perpendicular to A at point A. Now, any line through point A within plane sigma, which is perpendicular to A, would be perpendicular to A, because if A perpendicular to an entire plane, it's perpendicular to any line which is crossing the point A. So, if any perpendicular to A should be in that particular plane, then this perpendicular also must be in that plane. So AB actually belongs to, let's call it common perpendicular H. So H, AB equals H, and it's supposed to belong sigma, my plane sigma. Now, similarly, if I will draw a plane which is perpendicular to B to line B at point B, something like this, I don't know if it's a good representation, but anyway, this would be invisible. And let me wipe these two planes as actually not really needed. And this is not really needed. I just draw it for illustration from the very beginning to say that lines A and B are okay. And this plane would be, let's say, tau. So I know that tau is perpendicular to line B. Point B is where this perpendicular plane is actually I wonder if this should be also something like this. Okay, and I also can say that H also belongs to tau. Why? Because again, since tau is perpendicular to the B at to line B at point B, all the perpendiculars to line B at point B lie in this plane, which means H is as well. So what can we say from these two things? That H is an intersection between this plane, which is perpendicular to A at point A, and to this plane, tau, which is perpendicular to line B at point B. So if I know these 2 points, A and B, then basically I can also say that this perpendicular, common perpendicular to both lines, lies on the crossing of these two planes. Well, okay, fine, but the problem is I don't know the points A and B. I don't know where to draw these two planes to intersect them and to get my point H, right? Well, okay, of course I don't. Let's just think about the following. Let us have any point B prime, let's say, B prima on the line B. Let's just choose it completely randomly. And also have some kind of a perpendicular plane at this particular point and call it tau prima. Okay? Now, obviously, all the points which are perpendicular to B prime, all the lines which are perpendicular to B prime are lying in this particular plane. Now, if I will intersect the plane sigma with plane tau prime, somewhere I will get some kind of an intersection. Let's call it H prime. Now, this H prime will be an intersection between this plane and this plane, which means it should be perpendicular to this line at point B prime and perpendicular to this at point A. But I don't know point A either. So let's just choose any other point A prime and have a different perpendicular plane sigma prime at this point. And again intersect it with this tau prime. So basically I switched from unknown A to basically any point A prime, and from point B to any point B prime, have perpendicular plane here and perpendicular plane here. And what will I get on the crossing of these things? On the crossing of these things I will have a mutual perpendicular, obviously, right? Or not? Well, actually not, because this point, the mutual perpendicular doesn't really pass through these 2 points. It goes somewhere. These 2 planes are intersecting somewhere, not necessarily going through the B prime and A prime. So it's just 2 planes. This is perpendicular to any chosen point B prime, and this is the plane perpendicular to A at any chosen point A prime. And they intersect somewhere. But what's important about this line, this line must actually be parallel to this one. Why? Well, because again, it's almost perpendicular to this line. Why? Because let me just draw another picture and you will see why. So if you have one line and you have a plane which is perpendicular to this line somewhere, at this point, and then you have another line and you have another plane which is perpendicular. You know what, let me just start from the planes, that would be easier. I will draw the planes like a book. That would be one plane and that would be another plane, and this would be their intersection. Now this plane is perpendicular to this line, and this plane is perpendicular to this line. Now, lines are not intersecting. So, what I'm saying is that any line within this plane is perpendicular to this. This is B, this is A. And any line which is going through this point is perpendicular to this guy. Now, how about this common line? Well, the common line, let's do it this way. If you, let's say, draw within this plane, and this plane is sigma prime and this is tau prime. So if you draw in this plane line parallel to this one through this point, this is A prime. This line is parallel to this. This would be perpendicular to this line, right? Same thing here. If you draw this parallel to this from this point, then this line is parallel to this one. Now, but these are perpendiculars because the whole plane tau prime is perpendicular to B and the whole plane sigma prime is perpendicular to A at this point. So what I'm saying is that the same line would be parallel to a perpendicular to this and parallel to perpendicular to that. That's what's important. That's why I'm saying it's almost perpendicular to both of them, but it's shifted somewhere. So if I will be able to shift this line in a proper position parallel to itself, somehow find the position that it intersects actually both A and B, then that would be the proper line which would be perpendicular to both of them. Since this line is parallel to this, and this is perpendicular to A, and this line is parallel to this, and this is perpendicular, then there is a hope that I will find a mutual position so that it intersects both. How can I find it? Well, here is a simple way to do it. First, I will shift this line, and this is, if I'm not mistaken, is H secunda in my abbreviation. So if I will shift this to let's say this place, I can do that, right? Remember how I started? I picked any point A prime, any point B prime, and draw planes perpendicular to A and B in these two lines. And this is something which I have constructed. This is intersection between two lines. Now, since I know the point B prime, I can draw a perpendicular within this plane tau prime, and so this line is basically shifted so that it intersects B. Okay, fine. I found this line. It intersects B. Now I have to shift it along B until it will hit A. How can I do it? Well, very simply. Let's draw a plane which combines H prime and B, and within that plane, I mean, this plane should intersect A at some point, right? Let's call it A. So if I will start shifting parallel to itself along the line B until this particular point, then this point actually can be the base of the perpendicular, because this is parallel, so this is parallel. So what happens? Since this is parallel to this, and this is parallel to this, and this is parallel to this, and this angle is 90 degrees, then this angle is also 90 degrees. So it looks like it will be perpendicular to A, but we are pushing this line parallel to itself along the B. So it used to be perpendicular to B, so it will be perpendicular to B. So this angle will also be 90 degrees. So that's how basically I'm analyzing the whole problem. First, again, I choose two points on two lines. I draw two planes perpendicular to the lines at these points. take the intersection, and all I have to do is just to shift this intersecting line parallel to itself in such a way that it crosses both A and B. First I shift it to cross the B, and then I shift it along the B until it crosses the A. Until the plane actually crosses the A, and this plane is the base of one of the bases of mutual perpendicular. So this is the point A actually, and when I drop the perpendicular, that would be point B. So that's my analysis. So what I kind of guessed is that this line, which is not the one which I'm looking for, but it's parallel to the one which I'm looking for, can be obtained using two planes perpendicular to two lines which I have been given. And this is already a very important step. I cannot build directly the line I'm interested in, but I can build the line which is parallel to it. Fine, that's a very big step, because now all I have to do is to shift it from position to position. And that basically completes my analysis, and now I can start constructing. So what's the construction? Basically, I already told about this. Pick point, pick another point, draw a plane perpendicular to A in one point, draw a plane perpendicular to B another point, got the intersection between these two planes. Then I'm drawing from B prime a line parallel to this intersection. This will be H prime. Then I build a plane based on B and H prime until it intersects line A. And from line A, I drop the perpendicular to line B, getting point B. So AB would be my basically construction. Now, okay, after the construction, question is, what if I will choose another methodology? Will I have a different common perpendicular? Well, first of all, let me give you another methodology. There is another way to solve the same problem. Some people might consider it's a little easier, some may be a little bit more difficult. Here is what I will do. Okay, so let's say this is my A and this is my B. What I will do, I will pick any point on B, let's say, and draw a line which is parallel to A. And on A, I will choose any line, any point A prime, and draw a line parallel to B from point A. By the way, I do know how to do it. We did discuss it before. For instance, if you want to draw a line parallel to B from point A, you have to have the plane, which is defined by the line and the point, and within that plane, you draw the line parallel to B. You have a plane geometry. Now, these two lines and these two lines constitute basically planes. So you can consider that these two lines define one plane and these two lines define another plane. What's important is that these two planes are parallel to each other. So you can actually draw something like this. This would be one plane and this would be another plane. And these planes are parallel. Again, when we were talking about parallelism between the planes, we were talking about if you have two lines which are parallel to another two lines, intersecting lines obviously, on another plane, then the planes are parallel. Okay, granted, the planes are parallel, and what should I do about it? Here is what you can do. If you can basically project this line A onto this plane, let's say this is sigma and this is tau. How to project? Well, have 2 points and drop 2 perpendiculars from these points onto the plane tau and connect them. That would be a projection of the line A onto the plane tau. So that's where they intersect. This would be, let's say, A secunda, a second. Now, if these are where they intersect, let's call this point B, I construct the perpendicular up. Now these are parallel lines, and this is also perpendicular to the same line A secunda. So they're all lying in the same plane. So it will cross it at A. That would be a common perpendicular. Why? Well, very simply. This is perpendicular to the tau, and this is perpendicular to the tau. And this, therefore, is perpendicular to the tau. And since it's perpendicular to the tau, this is the right angle. Same thing here, we dropped it perpendicular to this line within this particular figure. So that's a common perpendicular. That's another way to approach it. Now, I'm not really, yes, basically that's kind of a combination of analysis and construction. Now the question is uniqueness. Now we have two methodologies how to construct a common perpendicular. Question is, will we get the same result? Is it possible to have two different common perpendiculars to skew lines? Well, let's address this issue. So let's again let me check. Maybe actually I can use the same picture. So if this is, let's say, A and this is B, and I choose the point. Now let's assume that I have two perpendiculars from one to another. So let's use my same picture as I did before. This would be A star, this would be B prime, A prime, B prime. Now I projected the line here. So now what I'm saying is that there is one perpendicular AB, and let's say there is another from B to A, let's say CD, also perpendicular. Now, how can I prove that they are supposed to be one and the same? Let's just think about it. Well, now I know that A and A prime are parallel, right? Which means they're supposed to lie in the same plane. Now this is perpendicular, and CG is also perpendicular, but it must not lie in the same plane, obviously, because otherwise, I mean, if it's the same plane, this point would be exactly the same perpendicular as this one, and this is longer. So between the parallel lines, all perpendiculars should be the same lengths, right? So obviously they are not supposed to be in the same plane. So C is somewhere, let's say it's behind or whatever. All right. So how can we prove the uniqueness of this? Again, we obviously should assume that A B, C, that A and C are different and B and D are also different, because if one of them is one and the same, like from the same point, we cannot have two perpendiculars, because that would be in the plane ABD we will have two different perpendiculars to the same line, which is impossible, right? So we should assume that they are all different. Okay. All points are different. So now we have to prove their uniqueness. So this is common perpendicular. Here. B is parallel to B prime, and A is parallel to A prime, which means that AB is perpendicular to an entire plane, since it's perpendicular to two lines. Same thing would be CD, is also perpendicular to an entire plane. So let's do it this way. Since if I will drop a perpendicular from point C to point to this plane, since B and B prime are parallel, AB is perpendicular to the plane, and I just drop perpendicular to the plane. It must hit the line B, because B and B are parallel, they are lying in the same plane, therefore, and in that plane, if I will draw a perpendicular from C, I will hit this point. So it looks like I have dropped one perpendicular from C to the plane, and then another perpendicular into a completely different point. So it looks like I have two different perpendiculars to the same plane, which is impossible, because this line in between them must be perpendicular to both of them, this one and this one. And within this plane, defined by C, let's call it C prime, and D, I will have within that plane two different perpendiculars, C prime and CD, to the same line C prime D, which is impossible. So that proves that we can only have one perpendicular to skew lines, to lines which are non-parallel and non-intersecting. So that completes the whole problem. As you see, I have spent a lot of time actually to first analyzing the problem, then offering two different ways to solve it, and finally I had to prove that these two different approaches result in the same common perpendicular. That's the complete solution. Okay. Now I think what's important for you is, number one, read the notes again. And what also I would suggest you to do is have a piece of paper, close your computer, don't look at the board, whatever, and try to write down with letters, with whatever mathematical symbols you want to use, the whole solution to this problem. First analysis, then the construction, and then the proof of uniqueness. You might actually come up with a third way of doing it. I suggested two different ways to construct it. You might come up with a third one. That's fine. You want to send it to me? Fine too. I'll publish it on the website. But in any case, I think it's important for you to repeat basically all these logical steps. And that's extremely educational if you will write it down on a piece of paper slowly. It will probably take you at least a day or something like this. Couple of hours for sure. So let's do it, and that would be extremely beneficial for you. Well, that's it for today. Thank you very much, and good luck.